Hello, everyone. Hi. My name is Leonardo Beradino. I'm principal developer at Groundswell Cloud Solutions, and I would like to thank you, everyone that's here, attending my session. Today, I will talk a little about testing in Salesforce, and more specifically in Apex, and using a tool that we developed and is open source. I will talk about the tool and show the code as well. It's nice. Everyone that likes code, I show a lot of code here. And before starting, I would like to thank also Cactus Force for the opportunity to have this session here, and also the sponsors. And let's start. Okay, before talking about the unit testing, the framework, I would like to talk a little about my story and the development environment and software engineering. And I really like software development. I have a lot of personal projects regarding not testing, but regarding things like I like to do. But I also investing a lot in tooling for our company, Groundswell Cloud Solution, because Groundswell works with very large projects, very complex projects. We are specializing in these crazy projects sometimes the client needs to implement. And one way to ensure that the quality of this project is good is implementing tests, right? Implementing automations and automated tests. But about my story, I started in the 90s, developed software in this small computer here, the MSX, and the 8-bit computer, an old one. And I can say this was the dark side of my development story, because here I never implemented one line of testing. In the MXX side, I learned how to develop software using BASIC, a little of assembly, Z80, because it's a very slow computer. After that, in the 90s as well, I started working with Windows and professionally with Borland Delphi, developing software for companies, also no tests here. And in the early 2000s, I started to develop for web. And this time, I was working with ASP, not the .NET one, it's the very old one, Visual Basic, C++, and our Internet Explorer 5, that nice browser. Yeah, and also no tests. Usually in this time, what we did was we had people testing the software, but no automations. And you can imagine how crazy it is if it changes something, the fear to deploy in production because we don't know if we are breaking something, right? After that, in 2003, I started to work with Java, WebSphere, and other technologies. Here, I'm just highlighting the main technology I worked at, and here I start my story with testing, right? Writing Java code, writing unit testing. I started to learn with other software engineers, very good people working with me, and I started to learn how to implement unit tests, how to implement the automations to run these tests. And in 2011, I started working with Salesforce. Salesforce as a CRM and other technologies like Java in this case here, working together. Usually the companies, the core software were like in Java or other language, and using Salesforce as CRM and integration. And I was surprised when I started working Salesforce regarding the tests, because we had that barrier regarding the coverage. We need to have 75% of coverage, and I saw that, whoa, this is pretty nice. I need to implement tests, because without tests, I cannot deploy to production. This was great. And after that, I continued developing other technologies like Node.js and Salesforce as well, working with core system in Node.js and Salesforce and .NET. And currently, I'm currently at Groundswell, I'm working with Salesforce basically, and technology around Salesforce, right? However, all this path here, I learned a lot about unit testing, about integration testing, and also about tooling. Because what helped me to implement, or helps developers implement good tests, is have good tooling. Salesforce gives us an environment for running tests, implementing tests, but for some cases we don't have a good tooling for Apex. right? And this is why I'm talking today about the Apex mocking framework. And one thing that I learned in this journey was how this framework works, how, what they are delivering for us, what tooling they are giving us to help us to develop the unit tests. And the idea that we have in the Apex mocking framework, they're coming from these other frameworks because they have years and years of experience of developing tests, right? These frameworks, let me check here. The TestNG. TestNG is one that I used in 2005, I think 2006. It's a very old one. And I learned a lot with these frameworks, okay? And one question I'm bringing here is why did we build the Apex mocking framework? Because we have an environment to develop tests inside Salesforce, but we have some issues, we have some problems, and mainly with big projects, when we have a lot of automations, we have a lot of customizations, we need to implement partially things in Flow, but we need also to use Apex, because Apex gives you as power, is a powerful tool to implement complex things in Salesforce. And what are the principles that we were facing with the implementation? First, the unit test implementation in Salesforce. First, the unit tests, usually they look like integration tests, right? Because if you see my diagram here, I have the unit test A is testing the controller A. However, this controller is calling the services, the unit of work, the selectors, the database, the triggers, and so on, right? And this takes a lot of time. It's a heavy process to run. But if I need to test the service A, what I'll do, I'll implement the unit tests for the service A, and what will happen? Everything will be called again. I need to have again the data inserted to the database. I need to have again this all process, all modules being called, and this takes so long to run, right? And you can see this, what we are trying to deploy the code. And another issue that is related with the previous slide is the data model. Sometimes we have very complex data models, like this one here. This is from FSL. We have accounts, case, contacts, work orders, service territories, product required, and that green product consumed, you can imagine if I have a business logic implemented in Apex that deals with that object. What I need to do, I need to create a data structure, or I need basically to create all that data structure in my test to run my unit test. This means that to create the product consumed, I need to create all dependencies, the product required, the work order, and so on. And this is created usually in the test setup. When we are running the unit test, we go to the test setup, insert the data, right? And this is very complex in this case. And after that, we can run our test that will consume that data. But what is the problem? It's not only data, because when we are inserting data, we need to deal with the validation rules, we need to deal with triggers, we need to deal with flows and other automations, right? Sometimes to insert data in these complex mods are very, very hard. And this creates a very complex code to generate data for my test. I cannot just right out of the bat and start to implement my unit test. First, I need to spend a lot of time to implement a logic that will insert data that will be used for my unit test, okay? The same for the product required. If I'm creating another unit test for the product required, what I need to do, the same thing. I need to insert that data again, and this takes time. The same for the service appointment, and so on. Another problem is this one. The deployment, okay, usually takes a lot. When you have large environments, large orgs, and we need to deploy that code, we need to run the tests. Sometimes it takes 30 minutes, 1 hour. I haven't seen like org that takes more than 2 hours to run all tests. And sometimes this happens, it fails. And what I need to do, I need to go there, check what is the error, fix the test error, and try again, more 2 hours, more 30 minutes. And you can say, oh, but I can do a partial, I can run partially the test on just class. Okay, but I'm not fixing the issue, right? I create a workaround, I run just a set of tests that will pass, but I cannot run, you can imagine my CI can run nightly, a build that run all tests to check if the merge or the rebases or everything that we implemented the previous days, it was working fine, didn't break anything. And you can imagine having a test that takes like, the set of the test of the org takes like 2 hours to run. And this is the idea, is to fix the issue, not to create a workaround. And when you have a small org, this is not so visible, but when you have a big org with millions of records of data, a lot of Apex, a lot of triggers, flows, and so on, this is very critical, okay? But before talking about unit tests, we need to understand what are integration tests, okay? Basically, the integration tests, they are different from unit tests, but they need to work together with unit tests. Usually they are for test the modules in my application, if they are working well together. If I have a controller, the controller is calling a service, is working together, this dependency. When I passing a data to the controller is sending the right data to the service is doing the right thing and passing to the next layer and so on. This is the idea of the integration test, okay? And they are responsible for assessing if different modules work well together. I'm checking if my controller is working well together with the service or with the repositories or other parts of my code. Also, another important part of the integration test is to evaluating the system compliance with the functional requirements. Basically, the integration tests, they should reflect the functional requirements, right? And this is the big picture about the integration test. Basically, the application is a black box. I cannot see what's inside. And usually what I do is, when I create an integration test, I go to the entry points of my application, and I create the tests for that specific part. And like my integration test can test like a controller, can test like an API, but it's not testing what's happening inside the application. It's testing just the entry points, and also testing all layers, and also the database, and so on. Okay, but if I open that black box, I will see the entire application, what the application has under the hood. And in this case here, we have a lot of things, right, happening inside. And for the integration test, doesn't matter what's inside. Basically, I need to know what is my functional requirement. I need to implement my test that will reflect that functional required. However, everything that's inside will run, right? Triggers, flows, so on. And the integration tests give us this feedback if everything's working together, well together. But we have a cost about regarding this because, yeah, I need to run everything, I need to insert data, and so on. This takes time. On the other hand, I have the unit tests. They are totally different from the unit tests, right? This is for testing the individual modules of my application. In this case, modules, it could be a class, it could be a component. Okay. Basically, the unit tests, they are very low level. They are different from the integration tests that they are based on the requirements, functional requirements. The unit tests, they are based on the implementation itself of that class or module or component that I'm testing, okay? And usually what I need to do is different from the integration test that I'm testing the endpoint that's calling everything is inside. Unit tests, what I need to do is usually decouple my class, remove all dependencies, and test only that class. One thing that's important to note here is they are very easy to parallelize. This means that they run very, very fast because I don't have the dependencies around my tests. I don't have that dependency being called and calling the database or calling the external services. And I don't have problem with states because they are just isolated. This means that I can run these tests easily in parallel. Okay, they are very light and very fast. Okay, and here I have an example. The same picture that I showed before. This is the big picture of the unit test for the application. Basically, what I have a unit test per module here. And you can see I don't have arrows pointing to the other modules. Why? Because if I'm running the unit test for the API layer or that component, this will not call the service. If I test the controller, this will not call also the service, and so on. And another important part is not calling the database, because database is a slow resource. The code that I'm running in a processor is like nanoseconds to run, but in the database is milliseconds, like thousands of magnitudes slower than code, right? And this is the idea, to decouple everything, decouple from the database, and try to run the code as fast as I can, okay? And you can think, okay, if the unit tests are so good, I can just implement unit tests. But the unit tests will not cover all my application. This is why I need to have both sides in my application. I need to have unit tests, I need to have the integration tests. The unit tests, they don't replace the integrated tests. And one part that's important is usually we have more unit tests than integration tests. I don't have a number because this will be different according with the application, right? You can be 10%, 9%, 8%, 20%. I work in a system that we had like 9,000 unit tests and 3,000 integration tests, a huge system, right? But you can see the number of integration tests is small compared with the unit tests. And this is the idea. Each test has their own purpose, and we can use them as a tool to test part of my system. Integration tests, you test everything, but I only will have a small set of tests, integration tests. And unit tests, you test each part of my system, each small component. Okay. Okay. I talked about the unit test being a class that should be isolated, but okay, how can I isolate the class? Because if I have a controller that's calling a server, I cannot just delete the server, because what will happen is I will have a compiler error, right? And what I can do is just replace that dependencies by mocked classes, okay? And here I have a good example. I have this service that is calling two different servers, a selector and a unit of work to insert or update the data in the database. What I did here, just replace these two servers, the service mock and the unit of work, by these mocked classes. And now I can run my unit test. The service will see that classes as dependencies. However, that mocked classes will not call the database or do heavy stuffs, okay? And what is a mock class? This is important because I'm talking about mock classes, and what is a mock class? Okay, basically it's a fake class that I can examine that class after running the test. This means that I have a mock class, I can define, oh, my mock will be called by my controller, right? My controller is calling that service mock. After the test running, I can just go to that class and check what happened with that class. Okay, I'll show this in an example, it will be more clear. And I also can define the behavior of that class, because if I'm not implementing a mock class, basically, how can I set the behavior of that class? Because that class needs to do something. It has, if I have a service that my controller is calling, that service is doing something. It's returning something from my controller. If I'm replacing that service by a mock, how can I implement or do something that mock that will reproduce what's happening in the real class? And this is the idea. In the example here that I put in the slides, basically I can define that my mocked class can return a specific value or can throw an exception due to a specific case. And I also will show this in an example. Okay. Okay, code time. Let me go to the code here. Let me know if you can see the code well. Is it good? Okay, cool. Let's go through here what I have here. This is a service example. A note here, this is not a production code, right? It's as simple as possible for this demonstration, right? And I would like to show you like a case that we usually see in implementation inside Salesforce. First, I have this method here for my service, cool message, that is calling a dependency, right? That will get a lead using the lead ID, and will return a message. Pretty simple. Let me increase the font size here. Is it better? Okay. And one thing that we can note here is I'm using static methods. This is very common practice in Salesforce, using static methods. And this creates a problem, and I'll show what is the problem. And okay, I have here the dependency. Let me open the dependency that you can see the code. Basically, it's calling the database and getting the lead, retrieving the lead from the database and returning to this service, okay? And now I have my test here, okay? And like I mentioned before, I need to go to the test setup because I'm not mocking the classes. I'm just calling the real, I'm calling the class that's calling the real dependency. This will go to the database to get the lead. And I need to create the lead before running the test. Usually we create a test factor or something like that. This is a very simple example. Here you can see just creating a lead, inserting the lead to the database, nothing fancy. However, usually we don't have a so simple example like I showed you in the FSL model. We have a crazy model with a lot of things that can block my insertion, like validation rules and so on. But for the sake of this presentation, I'm showing the easiest way to do it, okay? And if I go back to my test, basically what I'm doing is getting the lead ID that was inserted in the setup, right? Calling the service that I'm testing here, right? And just asserting if the message is the name that is coming from the lead plus the message I just added, okay? And I can run the test here. Okay, it's running fine, okay? But you can see it just doing the normal things. If I have a complex implementation, this will call a lot of dependencies. I need to insert a lot of data in the database, and for sure, this will take a lot to run. And if I multiply this for the entire system, doing the same, doing what I showed in the first slide when we are comparing the unit tests with integration tests, when I test the controller, it's call everything. When I test the service, it's calling everything again. You can imagine this will be multiplied by the number of tests I have, okay? And here, I will show again, I'm mocking a class, but without a tool, okay? It's the same example. I have here the service, but I change one thing, okay? First, I don't have the static method anymore. What I'm doing here, I'm creating here the dependency, right? Is instance, a static instance, and I'm just calling it here. And I'm using test visible to make this private field visible for my test, okay? The other parts are the same. Just calling the lead is not a static method as well, right? Getting the lead, getting the first name, and returning the first name plus that test. And now let me go to the test now, okay? Oh, I forgot to show one thing. Let me go back to the dependency. Okay, this is the dependency. One thing that I changed here is I implemented an interface, okay? This interface is here and just implemented the method here. And I will show you why I'm doing this, okay? And here inside, I didn't change anything. If I go back to the service, okay, if you can notice here, I'm not assigning the new instance to the class, but to the interface. And I'll show why I'm doing this, okay? This is the manual process to do it, okay? The manual, but after that, I'll show how to do it using a framework that can help you to do it. Go back to the test, and here I'm preparing the test. I don't need to insert data in the database because now I'm replacing that dependency that is going to the database by a mocked class, okay? Just generating a random ID, okay? Oh, let me comment this part here, sorry. Just generate a random ID here, okay? I'm creating the mock here. And this is the trick. Here the mock class is this service to dependency mock, right? And I created here in the factory this method that is creating the mock. There's a lot of code because I'm not using a tool, okay? And what this guy is doing, basically creating an instance of this mock, okay? And here you can see the mock. It's just a class that implements the same interface I have in my dependency, okay? And the get lead instead to go to the database, the mock will return what I set here in this public field, okay? And I also store in here what I received in the lead field, okay? Okay, come back to the test here. What I'm doing is I created the dependency. Now it's not a real class. This is the fake class, right? I set in what ID I would like to pass to the class, and I set in what is the returned value, okay? I'm replacing here, if you see here inside the service, this is the real class, okay? And if I go back, what I'm doing is replace the real instance by the mocked instance, okay? And now I'm calling the service too. What will happen is, when cool message is called, you call this guy here, that is that field, but now inside this field, I don't have anymore this instance. I have the mock instance, okay? Just replace one class by the other class. And this will run without going to the database. And you can see Salesforce here basically is the data that I'm passing here. I'm defining to return. But what's the problem with this approach? It will work, however, I need to implement a lot of code. And when I implement a unit test, I don't want to spend time creating a tool or creating these classes or artifacts that I need to use to my test. I can just jump to the test and write my test. I don't want to worry about, oh, I need to implement that mock class, I implement that thing or that. This is the idea of having a framework. If you go to Java, .NET, Node.js, Python, so on, we'll have frameworks that are doing this job for you. And why in Salesforce we cannot have the same thing, okay? And here you can see the test is running, but it's not going to the database. I could test here, I could assert the value without inserting any data in my test. Have anyone here seen this API before? No? Yeah, this is not so known API from Salesforce. It's called Stub API. It's a very powerful API that they give us to do exactly this process, is to generate mocks from classes, okay, automatically. I don't need to write that mock class that I showed in my example, okay? And here I have a glance of the API. Basically, I have an interface. I have that stub provide interface, and I have the test.create stub that I need to pass my provider, okay? And what this API does, it allows us to create mocked objects from classes. If I get my service and pass to the create stub method, the create stub will return a mock class for me. It can handle method calls. This means that I can, after testing, check the mock and check if a specific method has been called, or I can check what are the arguments that mock received, and I can also define what will be the return value by that method, that class or that method, okay? However, it's a very low-level API. You can see here the interface is pretty hard to understand, and it's pretty hard to implement as well, okay? And also I have the same problem. I would like to use the API, however, I cannot right off of the bat, start writing my code. I need to go there, implement the Stub, implement a class that, I need to create a class that implements this interface. And I need to understand this interface as well, how it works. And for each unit test I'm creating, I need to recreate a provider for that specific test. And this is not what I want. What I not want is go to my unit test, just start writing my tests. And this is why we created the Apex mocking framework. It's a powerful tool that's helping us to improve the unit test creation. It's basically for unit testing, not for integration tests, okay? And it's open source. Right now it's in the version 1, and the version 2 is not released yet. I will show you some features from the release 2 as well. Okay. And basically what we did was we got the Stub API, and we just encapsulated that complexity of creating providers, dealing with all that arguments, parameters, and so on. We encapsulated inside the Salesforce, the Apex framework. You will not see the Stub API. We will see a fluent interface, easy to use. And I'll show this in an example. Okay? And basically, this API, you can do a lot of things. You can define, you can call the API to create a mock. You can define for that mock that I want that mock that returns a specific value or throw an exception. I can also use some tools that I'll show here that allow us to do magic things, okay? And it will be better to show in an example, okay? Code time. Let's go again to our example here. First thing, this is the same example I showed before with the same idea. However, you can see here, I don't have any class here regarding tools that I need to create my tests. If you go back here, I have the test factory. Inside test factory, I have the mock, and I need to implement all of these crazy things, allow me to mock my class. However, if I'm using the framework, I don't need to do anything. I can go, let me go back here and increase the font size. Okay. This line here, I showed a second way to do it, okay? Basically what I'm doing here is a lazy creation, okay? You don't need this, okay? You can use the same approach we have used in the other example, but here I'm just showing a second way to do it because sometimes we have a lot of dependencies in our classes, right? And if I just start creating my classes from here, okay? All dependencies, what will happen is when I using this class, all dependencies will be created right away. And sometimes I don't need this, okay? But don't worry, this is just a caching basically for dependency, but you don't need to use it. You can just go and stay with the same solution here, okay? It's the same thing. Okay, the service here doesn't change anything. It's basically my dependency, and I'm calling here the dependency, right? And doing the database retrieving for the lead, getting the name. And here there's a change that I would like to mention. I'm using name, not first name. And this is important, I'll show why. Because name is a read-only field. I cannot go and just create new lead and set the name. If I try to do that, we will receive an error that's a read-only compilation error. Here's my dependency. Nothing changed. Increase the font. Okay, nothing crazy. And now the tests, okay? Now I go step by step in the test here, okay? Here I'm using the mocking framework. And first what I'm doing is specifying for the mocking framework because I have some phase inside the mocking framework. I have the stubbing phase, the phase that I'm just saying what the mocks classes will do. After that, I have the act phase that I'm executing my tests. And after that, I have the assertion phase that I will test what happened, okay? And I start in here saying, oh, mock framework, I would like to start recording or creating mocks and defining the behavior of these mocks, okay? And here I have the first utility. We have this utils from the mocking framework, and you can call to generate an ID. And you can pass what is the S object type here. This will give you the correct ID for that object. You can also define here a number if you want, right? But if you call this generate ID multiple times, it will generate different IDs. Number 1, number 2, number 3, number 4, and so on. And the correct ID for the object that you are defining here, okay? Now I have a fake ID here because when I'm getting something from the database, an object, that object will came with an ID. And here I need to reproduce that same behavior that the database is doing, but in memory, okay? And here I started to create the mocks, okay? Instead to have that class that I created to simulate a mock, what I'm doing is just going to the mocker and say, mocker, please create a mock class for its service for this dependency here. The mocker framework will return here an instance that is not the real class, right? But as a mock, this class is not doing anything. I don't have anything implemented inside. If I call the method, it will not return anything because I don't have any code inside the mock. But what I can do is go to the mocker and say, when this method here, right, get lead, is called with this ID here, I would like to return a lead. And this lead is being created in memory. Here, you can see. Lead and ID. Here I'm showing a second thing that we have in this utility is update object state. And this is the magic thing. I can set formula fields, I can set read-only fields, I can set, if I have a dependency, I have like work order and work order line items. I cannot set inside my objects that collection that contain the line items directly, but I can do it using this utility. This means if I have, you can imagine if I have a lookup field in an object and I have here a relationship with leads, I can go there, I can imagine, I don't know, lead, children, records, just an example, right? You can go there and just set that field using the utility, even if the field is read only or not, okay? And this gives us the power to create a class and create the children objects as well and set that list, okay? Okay, now what I have is, I have my mock. I defined the mock that when this method is called, you return that lead, okay? Now I'm just replacing the real instance by the mock class, the same thing that I did before, but without implementing anything. And then now instructing the mocker saying, now I stop at the stubbing phase, I'm not adding any new behaviors, I'm not creating new mocks, and I can start running my tests, okay? Now I'm just calling here service 3, call message. What will happen is, this guy here now is the mock, is not the real one, new real class. And when this method is called with this ID, what will happen is, this lead here will be returned automatically, okay? And here you can see Cactus Force is exactly what I'm passing here and what is being set in the name here. You can see name, Cactus Force, you set in the lead name, even being a read-only field, okay? This is the idea. Let me run the test here. Okay, you can see it's passing. If I change it here, oh, I need to wait deployment. Sorry. Try again. I need to wait to deploy. Okay, let's go because I don't have a lot of time. Okay, let's get another scenario. I will show you a more complex scenario. In this case here, I have the payment service that's calling the invoice selector, right? Here, this is the call. The invoice selector is going to the database, getting the invoice from the database. The payment service is checking the invoice and passing this invoice to the payment broker. And the payment broker is calling a service to perform the payment, to execute the payment. Okay, this is my test scenario. Okay, and like I told you, I'm just organizing my tests using this approach. I have the first block, this first session. I can call given or arrange. Just preparing my tests. Everything's in memory. I'm not reaching the database. I'm not calling trigger and so on, because my goal here is test the module, that specific module, the logic inside the module. Like I told you, the integration test will test the dependency, will test the database, the trigger, so on. After that, I'm in the second phase, the second section, when is executing the test, and the third one is just asserting what happened. Okay, this is the order that I'm writing the code. Let's go back to the code. But before showing what my idea is, before showing the code, my idea is to show this example now implemented using the mocking framework. Okay. Here I have the test scenario, right? I have the invoice selector that's going to the database. It's checking if I have an invoice. If not, I just throw in exception. Oops, let me increase the font size. Okay. I have here the client just simulating an external call. Okay. It's not doing any call because just for the sake of the presentation, just simulating. Okay. This is the exception, and this is the service that I will test. And now I have two dependencies, like I showed you here. I have one dependency here, another dependency here, right? And here's my logic. Basically, it's calling the selector, getting the invoice, checking if the invoice is good to be sent to the payment broker. Is the status correct, and so on, the amount, and calling the method in the broker client. This means my first idea here is to remove these in my test, is to replace these classes, the real classes, by the mock classes. Let's go to the test. Okay. Same thing, starting stubbing, creating invoice, because I'm simulating what's happening inside the database, right? You can see here I'm generating an ID. Now it's not a lead, it's an invoice. You can see I pass a different object because I need to have an ID that's compatible with this object, not with lead. I'm setting the status in the total amount, okay, because I have that logic inside my class. I have a if. I need to have the right status and the right total amount. Okay. Now I'm mocking the selector. Same thing, calling the framework, saying mock this class, this selector. And when the get invoice with this invoice that is called, I would like to return that mock class here. I'm sorry, I would like to return the invoice. The same thing for the client, but the client is not returning anything, right? I'm just mocking the class. Okay. Here I'm replacing the dependencies. The real dependency, I just replacing the pointer to that classes by these mocked classes, right? I'm replacing both. I'll go back here to my presentation. I just replacing these two guys here, okay? Now I have the memory invoice that I created. They will be returned. I have the payment broker mock, and now I can go and start testing. I just instruct the mock framework that I'm ready to start testing. I'm not creating more mocks or updating behaviors. Here is my test, pretty simple. Just calling the service and executing a payment of the invoice that is in memory. Okay. Here is a feature from the V2. In the V1, we don't have the expect feature, right? I'm showing this, but it's not released yet. Will be soon. And in the first version, we can do the mocks, we can implement we can define the return values and so on. However, we cannot use the expect, okay? The idea of the expect is make it more readable, my assertion. And I can say here, what I'm checking here, if a method has been called, right? You can imagine if I have a loop and I have a unit of work inside, and I just instruct a unit of work to go to the database insert inside the loop. This is terrible. And I can create a mock of that unit of work and check in my unit test if that insertion has been happened more than one time. And exactly what I'm doing here. I'm checking if my my class under test, the payment server, has called the getInvoice method with this specific ID, okay? And checking if it has been called once, okay? And this is a search in the execution, or the mock, okay? The same for the broker. I can check here if I'm executing the payment twice. I'm defining, okay, this method here, it should be called once. And here we can see one small difference. Here I'm passing the method inside this method class, and here outside. Why? Because this is a void method, okay? And is a limitation in the Apex. I cannot just pass a void method here, okay? Okay, now let me show you a little more about expect, okay? Because I can use expect for a lot of things. You can go there, define, I don't know, some value, right? Right? And I have a Fluent interface that I can define, oh, that expect value that was returned by my test class. I can check if it's null, if it's not null, if it's equals something, okay? Or if you can imagine if this guy here is a number. Unfortunately, we don't have generics in Apex, and this doesn't allow to identify what is the type of the variable, okay? But what we did here was, oops. I have the numeric value here, okay? This will change here what I can assert, okay? I can check if the value is closer to a value, if it's within a range, if it's null, if greater than, less than, so on, okay? And I also have the same thing for dates. If your value here is a date or date time, you have specific methods here for testing, okay? That date inside is within a period, if after a date or before a date, so on. This is inspired on the JAS expect. If you go to the JAS documentation, it will be basically the same thing, okay? And unfortunately, I cannot explain more about the framework in really detail because I only have 50 minutes. It's a talk for, I don't know, 2, 3, 4 hours, okay? But what we have is a blog post. This blog post is only regarding the version 1. Soon, when we release the version 2 with the expect, we can go to the Groundswell blog here and check the new blog post that I will do, okay? And also, if you have any question, let me check if you have time. I have 1 minute. You can just reach me here through my email or my LinkedIn. You can just send me a message. We have 1 minute. Anyone has questions?
From where to you say like it's open source?
Yes.
So is it in any particular repository like GitHub?
Yes, it's in GitHub. If you go to the blog post, in the blog post, there is a link to the repository, or we can go directly to go and search for GitHub Apex framework, right? Yes?
What's the advantage of using your framework versus financial products?
Yeah, this is not, this is a completely independent framework. You don't need to be coupled to any framework. You don't have any dependency. If you have a project that is not using FFlib, we can use this. And also with FFlib, if you want, we can use it as well. Basically, is to have a more flexibility and not be tied to a specific framework. With FFlib, if I would like to use the framework from them, the FFlib, I need to use FFlib. Yeah, depending.
And then you have to change your code around to use separation of
Here, basically, it's only the test side. I'm not defining any architecture for your project. This will work with any architecture we have. Since if you have the dependencies as classes, like I showed, instance classes, not static methods. Why? Because the Stub API doesn't have yet the support for static methods mocking. If they release, I will add it to the framework, okay? Even with generics. If they release generics in the Apex, I will add it here because it will make it easier to do some magic here. Okay, guys, we are out of time. I would like to thank you, everyone that, thank you for having me here. And like I told you, if you have any questions, please just reach me out, or here, or tomorrow. Tomorrow I'll be here, or via LinkedIn or my email. Thank you.